I didn't even know what
I didn't even know what happened.
It gets dark at like 4 o'clock.
I read something about it like 2 days after.
Because I felt so good this morning. I was
You
like,
just woke up and recognized your phone had a different time, or just?
No, I just woke up and I told
I
Greg.
slept through the morning.
Well, it is what it is, and trust me, the older you get, the harder it'll be on you. It just, these time changes are something else. I think we ought to just pick one and stick with it. So as you all know, we're wrapping up the end of the semester, and I was talking with Abigail yesterday, or not yesterday, when was it? Last week. And she had a nice story to tell about how her experience getting to do some shadowing in a lab. And so I thought I would start the morning off by having you tell your fellow classmates kind of how you went about doing that and what else. So
I want to research RNA chemistry, and I really like genetic expression. So I went on USM's research snapshots for the chemistry biochemistry faculty, and I just chose which professor their research was more in line with my interests. And whenever I emailed them, I basically just talked about I told them my transcript grades, my previous experience, like any other lab experiences that I've done, and I just asked them if I could either shadow or if I could participate in the lab for next semester. And I emailed Dr. Wong, and he said that I could shadow. So yeah, I'm currently shadowing in his lab. Yesterday was my first day actually. It was pretty cool. If any of you are interested in research, totally 100% go into it. It's really cool. But also if they don't tell you that, if they say that there's no more space in the lab, I'm sure Dr. Rangachari's lab is probably really busy. Don't get discouraged and just email the next professor.
yeah, so tell us a little bit about your first day shadowing. What was that like?
Okay, it was really cool. So we're working. I learned how to breathe. I didn't actually do anything, but I just learned the methods to do it so far. Just because I'm newer in the lab and my only real chemistry grade is Gen Chem 1. So I learned how to breed a colony of E. coli, and I got to watch them. And so there's something called a pH meter, and it's really sensitive. It's like a pH indicator, but it's super specific. And they actually did let me up the level of hydrogen in there to make the solution more acidic. So our pH, there's a lot of cool instruments that they explained to me as well, like a centrifuge and a spectrophotometer. And whenever we were reading the bacteria, I got to see an incubator, and I didn't realize how huge they were. They're this big, the size of the podium, and then those two things together. And let's see, I was toured around the lab. I got to wear a white lab coat. I did not expect an actual lab coat. I thought a true scientist. Overall, it was really cool. The lab environment was really nice. Also, the graduate, the research assistant, they were really welcoming. They answered all of my questions. I had a lot. And then the senior that I'm working with too is also really cool. So yeah, definitely get into the lab.
Good, fantastic. Anybody have any questions for her? What I will tell you is that anytime you get started, especially when you get started early on in a research lab, you'll have moments where you're like, what are they talking about? What's going on here? And it is kind of like learning a foreign language. But the only way to really learn languages isn't by coming to a classroom, right? It's about, well, of course you got to do that piece too, but I mean, you know, immersing yourself in the culture and in the environment and in the language. And that's really what you've got to do in science as well. Science, you may have heard me say this before, is a noun, but it's also a verb. We do science. I mean, it is an action thing that we do. And you will never get to a point in your education where it's just, now's the time to do research. other than the fact that we tell you by your senior year you have to do at least one semester of research. So I would highly recommend all of you to do what she did. Reach out to faculty when you feel like it's going to fit in your schedule. Go ahead and get started shadowing. It's an easy way. You're not committed to a grade. You're not committed to actually. I mean, if you decide that that's not the lab you want to be in, you don't have to come back, right? I mean, you can actually shadow a number of labs. We encourage you all to do that. And so, the fact that she went out and found a lab to go shadow in, I wanted you all to hear that experience, hear what it was like. It's not scary. Faculty aren't going to, they may say no because of how full the lab is, but most faculty with shadowing don't say no. I mean, shadowing's easy for us too. I mean, we'll schedule a couple of days for you to come by when we've got something going on that might be of interest to you. And see whether or not you like it. Because at the end of the day, when it comes time for you all to pick a research lab to do your senior project in, it would be nice if you were in a lab that you actually enjoyed the work that was being done, so you didn't feel like you were doing something that didn't particularly interest you. And getting involved in that early is certainly the best way to make that happen. So for today, I'm going to pass out a reading assignment. I'm going to give you about 5 minutes to read this, and then we're going to do a little group activity. I got this from Science News Magazine. I thought this was kind of interesting. So we got to figure it out. Let's stick together. Here you go. So go ahead and spend about 5 minutes reading that article. It's not in Canvas. All right. Get into groups of 2, 3, something like that, just a couple of folks, a few folks. On the back of the paper, you need to print your name and put your ID number, and then you all need to have a discussion as to why I'm having you read this. How does this connect to things that we've been talking about in this class? So I want you all to hash that out, write a few things down, okay? Yeah, you all, you 2, yeah, you 3, however, you need to break it up, yep. couple minutes.
And you tried to study there. No, it's chicken too. Oh, really? I don't know. I'm gonna sense.
All right, folks. Let's discuss what we've come up with. So, why is it that I felt that this was important for you all to read? Don't fabricate data. Do you think they fabricated data?
I believe maybe.
You believe them? What did you say? I'm sorry. Go ahead. Okay, yeah, so we've talked about the scientific method, right? So what led you to believe that maybe they're fabricating data?
I mean, it was a claim made of it by a physicist who did math, but like, I don't know. I don't know if I believe the physicists. You're not just gonna believe anyone who's just critical about something.
Okay, all right. So is it fabricating data to, so what do you all think fabricating data is?
Just making up data to prove your point.
Okay, so if I gave you a spreadsheet of numbers that I just randomly typed in and I said, this is the data, that would be fabricating data, right? And I said, well, look, it fits a line. Of course it fits a line because I designed it to fit a line. That would be fabricating data. But they took the raw data and did something to it. They transformed it, right? They did some kind of analysis on it. That's where so is that fabricating data? Kind of? Okay.
Twisting the data.
Yeah, so they may have either intentionally or unintentionally mishandled the data. Okay? And so that's a different ethical question than fabricating the data. Okay? I don't think they fabricated the data. I think they transformed that data in a way that wasn't clear and really gave rise to, are you skewing the data in a way that favors your outcome? And they couldn't defend that, so the paper got retracted, right? Okay. So what else? Why is this important to a chemistry major?
We artists talking about how like research needs to be presented in a way that can be replicated by others because it's supposed to be like questioned and analyzed by other scientists.
Yeah. Yeah. So we're actually seeing the scientific method at work here, aren't we?
That's what I wrote about.
That's what you wrote about?
I said bring the scientific method in the picture. The
Yeah.
hypothesis first introduces the idea of a room temperature superconductor.
Yeah.
And then they conduct like a 2-day experiment. And then the data is like analyzed and yeah, they think it's like fabricated.
Okay. So you think it's fabricated?
He specifically says that
Yeah.
Our analysis proves mathematically that the raw data were not measured in the laboratory.
They were fabricated.
Okay. Yeah, I mean, it could be, right? So you're seeing the scientific method. Somebody had a hypothesis, as you said. They tested the hypothesis. They analyzed the data. They published the data. And then you're seeing something here that rarely happens, a retraction of a paper. That does happen. It's not it happens with regularity, but the number of papers that are published every year, it's only a very tiny fraction of a percent that ever get retracted, okay? And so that is the scientific method at work. You have put out there what you think. People have had the opportunity to critically analyze it. If you were that researcher, how would you feel about your paper being retracted? Embarrassed. How many people like to be embarrassed? Raise your hands. I don't know anybody who likes to be embarrassed, right? So what's the take-home message here for scientists?
You're not always right.
You're not always right? Yeah, but I cannot be right about something in terms of my interpretation of what the data says and be completely honest with what I've put forward, right? Okay? So what else?
I think it also shows that you should be able to perform your experiment again and again and be able to still get, like, basically in the same range of results.
Mm-hmm. Now, you all have been in Gen Chem labs, maybe in the organic lab at this point, right? And you've probably been tempted, if you're doing something in triplicate, hey, I got the answer the first time, why do I need to do it again? Right? Maybe I'll just write down those exact numbers again, right? You could, in theory, do that. But you need to be your own harshest critic, right? If you're your harshest critic and you hold yourself to a higher standard than other people will hold you to, you will never be embarrassed. You might be wrong, but you won't be embarrassed like this. It's okay to be wrong. You formulate a hypothesis, you test it, you end up being wrong, you publish it. That's okay. Nothing wrong with that. Okay, that's how science moves. But you don't want to be embarrassed. You don't want to get caught cheating, right? You don't want to get caught doing anything like that. And so that's one of the reasons why I thought this would be a good little thing for us to go over today. All right, let's finish up the day by talking about the things that I had put in the Canvas shell for you all. The interview with Daniel Hinton. What did you all think about Dr. Hinton? He's doctor now. He was not a doctor when I knew him long ago. But what can you take away from Dr. Hinton's messages? Let me tell you a little bit about Daniel. He started actually his research here at USM when he was in high school. He was an ACS Project Seed student, came in and did work one summer with Dr. Heinhorst in biochemistry. Came here, ultimately decided not to do biochem and just do regular chem. Joined my lab. I believe he was probably a late sophomore when he started doing research. And he did his research with me for a few years. Actually got a publication out of it and ended up going to, anybody know which university he went to?
Wisconsin-Madison.
Wisconsin-Madison, yeah. And Wisconsin-Madison is actually one of the top premier graduate schools for chemistry in the nation, and has been for quite some time. A lot of strong chemistry type projects are going on there all of the time. And so he got introduced to the work at Madison. I actually had gotten an email from them somehow. They had a program that they called CHOPS, and I forget exactly what it stands for, but it's to bring students in for like a weekend to see the department and get an idea of whether or not they might want to apply to Wisconsin. So, and it's a full paid kind of thing. You had to apply. It was competitive. So the fact that he was awarded this, they flew him out. He spent the weekend there, and ultimately he decided to attend University of Wisconsin-Madison. But what I will also say about Daniel is he applied to probably 13 or 14 schools and got accepted to all of them across the nation. So Berkeley, Johns Hopkins, the whole 9 yards. So, these experiences can make a difference as to where you choose to go, and that CHOPS program took him there. After spending some time in college, he decided he didn't want to be a professor. Daniel would have made a great professor, but he decided he wanted to be in industry because he didn't want to give up lab work. One of the things that we professors have to give up quite a bit is the actual lab work. You actually, when you're a professor, you end up being an instructor like I'm doing right now, and then you also end up being like a lab manager. So you do a lot of writing, you do a lot of budgets, you do a lot of making sure people get paid. You come up with ideas, of course, but you're rarely in the lab actually doing the actual work. So he didn't want to give up the lab work, so he went into industry, and that's where he's been ever since. I talked to Daniel probably a year ago, and he's even moved on from the position that he talks about there. He's now in Indiana at a company, I forget where it is. He and his wife needed to be in the same town, and so he switched jobs. But Daniel is definitely a success story. Starting off, kid from Petal, starting off as an ACS Seed Scholar, moving his way up here as an undergraduate doing research. And Daniel published, you all can go up on the 4th floor and see Daniel's work. It's on one of my posters out there. So he made this molecule called nipocatic acid, which is actually a molecule that can cross the blood-brain barrier and help treat certain diseases. And we found a way to make derivatives of it through kind of a novel method. And so he published that. And Daniel worked every bit as hard as a graduate student to get to that point. He was determined to get a publication by the time he graduated, and he did. So he set a goal for himself, and he achieved it. So that's Daniel's story, and he's definitely one of our former Golden Eagles that I think you all can look to and be inspired by and look to as kind of a mentor and role model. And Daniel wouldn't mind it if you all reached out to him and asked him questions or talked to him. Daniel's a great guy that way. And I think did I list on the video his email address at the end? I can't remember. Yeah, so hopefully that's still a good email address. If not, I'll try to get in touch with him and get a new one. All's good there. Dr. Wallace's research. Okay, Dr. Wallace couldn't attend class here for us because he teaches at exactly the same time we do this. So I used the video that I put together during COVID of Dr. Wallace's research. Can anybody tell me what Dr. Wallace kind of does in general?
He does stuff with inorganic molecular chemistry.
Okay, yep. So he makes sensors. He tries to detect things that are inorganic that might be problems in either industry or the environment. And so he makes these so-called supramolecular complexes that actually give rise to some kind of color change or some kind of change that you can detect so that you can identify these things. So how would you classify that research? Would you classify that as kind of analytical chemistry? Would you really call it inorganic chemistry? Would you call it organic chemistry? Would you call it environmental chemistry? Would you call it industrial chemistry? How might you all classify it? You can see bits and pieces of all those in that, right? So the take-home message there is that actually chemists can cross boundaries all the time. Dr. Wallace, I think he would tell you he's classically trained as an inorganic chemist. He's gotten into this supramolecular stuff. But he is just as much an analytical chemist as anybody else. They're doing a lot of analysis. Being able to detect a number of these inorganic anions is really what they kind of focus on without having to use real expensive equipment. So looking at color changes. It would be nice if you could make a strip of paper, and when you dip it into a sample, if the stuff's present, it changes color, and you can measure the quantity. So they're not quite to that level yet, but that's where they are headed with it. So Dr. Wallace is always interested in students coming and working in his lab, and so if you're thinking about getting involved or going and shadowing, Dr. Wallace would be a good one to reach out to. Okay? So, out of the chemistry book, I gave you all acids and bases to read this week. What did you take home from this little reading? Why did I pick this? Could have picked anything else, right? Why did I pick acids and bases? Most of the time in Gen Chem, what are y'all talking about? You're talking about acids and bases an awful lot. Acids and bases, the theory that Lewis came up with, and I'm not exaggerating here, if you all have a good, solid foundation in Lewis acids and bases early on, you will do better in organic chemistry, you will do better in analytical chemistry, and you will understand biochemistry better. You can really break down most of what chemistry is into a reaction between an acid and a base. A lot of times they don't look like a traditional acid or base. When you all hear the word acid, what kind of things do you think of? pH. What else? Lemons, acidic. So you think about acidic fruits, maybe vinegar, right? Those are all acidic things. What else?
Exchange of electrons.
Exchange of electrons, okay. What acids have you worked with in Gen Chem?
HCl.
Hydrochloric acid, HCl. Anything else? Hydroxide, that's a base, right? So that's good. So you've dealt with strong acids and strong bases so far, right? And so, but you can really break down chemistry into thinking about an acid reacting with a base. When you get to organic chemistry, you're going to be pushing arrows in a way that really talks about a base reacting with an acid. But it's not going to be hydrochloric acid or nitric acid or sulfuric acid or hydroxide. Okay, but you can really break down and simplify most chemistry into nothing more than a series of acid-base reactions. It's why DNA recognizes other strands of DNA. It's an acid-base interaction. You all will call that hydrogen bonding when you get to that, but it's nothing more than an acid-base interaction. You can think about why saran wrap sticks to itself. In terms of acids and base chemistry, you will be able to push arrows and draw mechanisms for how things are metabolized in the human body and biochemistry based on a series of acid-base reactions. So what I'm encouraging you to do through this reading is, as you're learning about acids and bases in Gen Chem 1 and 2, know that that's going to be a recurring theme in every class that you take as a chemist. In general chemistry, you'll learn about the ideal gas law, and you will not talk about the ideal gas law in every course. You will learn about the Van Hoff equation, and you will not talk about the Van Hoff equation in every class that you take. But every chemistry class that you take, whether they use the words or not, you will be studying acids and bases. And so it is the foundational thing that you all need to know. And Lewis, I think, gave us the best, most elegant theory of being able to see whether or not electrons were being donated or accepted. Once we understood that you could simplify acids and bases into electrons, that opened up that theory to everything. And that's the important thing. Before that, we were trying to figure out how things worked, and Lewis really did allow us to simplify it into a series of acid-base reactions. You all will hear the name G.N. Lewis several times. There's the acid-base theory. What else is it that he's contributed to that you might have already learned a little bit about? Lewis structures, right? So Lewis structures, how we deal with electrons, how we account for them, how we draw sticks and draw models, right? That's the Lewis structure theory. And then, of course, acids and bases. He is the most prominent chemist in history never to have won the Nobel Prize. I personally believe he should have won a Nobel Prize at least once, if not twice. Okay? The rumor has it he was a real pill. Nobody liked him. And so they denied him, in my opinion, they denied him a Nobel Prize. But I think I think even, in terms of Einstein and all these other people that you hear about being geniuses, I really think Lewis was a genius in the sense that he was able to simplify chemistry down to electron pairs. And if we understood what those electron pairs were doing, we could really understand the fundamentals of what was going on in chemistry. And so I think he simplified our field in a way that made it more accessible to folks. All right. So, you went to the research profile page, right? You can also go to, and I don't know if I've shown you all this, you can go to the USM faculty directory, it's just faculty-directory after USM, and you can search for any faculty member at USM on this particular one. So if we wanted to see, I'll just pick on myself, if you wanted to see things that I've been doing, you'll be able to find my areas of expertise. You'll be able to find, what discipline I'm in, yada, 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 my email address, all that kind of stuff. But if you click right here, okay, you'll be able to go to a biography talking about myself a little bit. You'll be able to see the publications that we've published in recent days. So if you're interested in that kind of thing, you could just simply click on these and it will take you, well, it was supposed to. I need to fix that one apparently. There we go, there's one that works. So if you were interested in seeing faculty's papers, you can get that information there quite easily. Let's go back. If you were interested in what Dr. Piggs is working on, again, you can find her bio, you can find her list of publications. Okay, so you'll be able to find that stuff, and faculty can keep this updated actually on a daily basis. So it's worth every now and then to kind of go back through and see what people are working on. The research page is a great place to start. The research page, however, I noticed when you were showing it, still listed like David Hayhurst on the research page. That hasn't been updated. Dr. Hayhurst passed away in the summer, unfortunately, and so he's not here with us doing that work. And so, but if you go to the faculty directory, you can search the faculty and see what your interests are. You can also search not just by name, but by other things as well. So, if you were interested in just chemistry, right, you can pull up, you can see Dr. Bateman, who's emeritus. Anybody know what emeritus faculty is? Somebody who's retired, but they're still affiliated with the university. There's Dr. Broom, if you're interested in chemistry education, supramolecular chemistry, inorganic chemistry. Dr. Cannon. Dr. Tristan Clemens is not in the chemistry department, but he's in the polymer building over there. He's a polymer scientist, but you can see he also includes the word chemistry in his, so you can actually search out broader than just what's in chemistry and biochemistry as a discipline and see who else has chemistry interests listed in their areas of expertise. So you can have all that kind of information. So there's Dr. Bridget Davis. She's a teaching professor in education, but she's interested in helping people learn about science. That's what she does. And so, again, it helps broaden out that list. So this is a great place to start as well. And you can put just about any term you want in that search bar and get to what you're interested in. Okay. The last thing I want to mention for today is I've started grading a lot, if you probably recognized. Your CV resume assignments, I've given you all comments. They are there as take them or leave them. It's your document. So, most of the points were awarded for most. However, and I can't remember who it was, there is one person that has uploaded on time. It was a PDF, but it's corrupted. So I've given you comments in there that I can't read the file. So if you would go back in, make sure that that's not you. And if it is you, there's instructions there to go ahead and send me your CV/resume by email today, and I will grade it as if it was turned in on time with no problem. It's just a file problem. Don't know what happened. The PDF viewer says it's a corrupt file, and then I couldn't read it at all. So I've graded the CV. I've graded your participation assignments. I still got some things to do in terms of attendance. And again, we're coming close to the end of the semester, so we don't have a whole lot left to do. So pretty much the grade that you see in there now, if you keep up the good work, is pretty well where you're going to end up at this point. Is there any questions about that? No? All right, well, I'll give you a few minutes of your day back. On your way out, please turn this in on that table right back there. This will count as your attendance for the day. And I'll see you all next week.